Pandas is a powerful Python library for data manipulation, offering flexible data frames for analyzing and transforming data. Snowflake is a scalable cloud data warehouse that provides high-performance storage and querying capabilities. Together, they enable efficient data workflows where you can push Pandas DataFrames into Snowflake for scalable storage and processing, or pull data from Snowflake back into DataFrames for local analysis. The integration focuses on optimized data transfer techniques, including automatic data type mapping, parallel processing for large data sets, and secure authentication methods. Recent advancements in November 2025 include enhanced Snowpark for Python, faster data frame uploads with reduced latency, and support for hybrid executions that minimize data movement and costs. Pushing data frames involves transferring data from your Python environment to Snowflake. The primary method is snowflake.connector.pandas.writePandas. This function creates a temporary staging area in Snowflake and efficiently uploads the data frame. Important considerations include automatic data type mapping between Pandas and Snowflake, handling large data frames by chunking, and optimizing for column mapping. Here's a code snippet demonstrating how to push a data frame using writePandas. Pulling data frames from Snowflake involves using pandas.readSQL with a Snowflake connection. This function executes SQL queries directly within Snowflake and returns the results as a Pandas data frame. To retrieve data, you first need a secure connection using snowflake.connector.connect. Configure essential parameters like your account, warehouse, and role for proper resource allocation. For efficient memory management, especially with large datasets, use chunked fetching. This retrieves data in smaller chunks rather than loading everything at once, preventing memory issues. The process involves executing the query within Snowflake's architecture, which optimizes performance through parsing, optimization, and execution before returning results as a data frame. This approach ensures efficient and secure data retrieval from Snowflake into Pandas data frames. To maximize efficiency in Pandas Snowflake integration, start by partitioning data frames for parallel uploads. This divides large datasets into smaller chunks that can be processed simultaneously, significantly speeding up the transfer process. Leverage Snowflake's copy into command for rapid data loading from staging areas. This command efficiently transfers data from external stages into Snowflake tables, handling bulk inserts with optimized performance. Scaling your virtual warehouse appropriately for compute is vital for handling varying workloads. Virtual warehouses provide the processing power needed for data operations, and adjusting their size ensures optimal performance without unnecessary costs. Snowflake's optimized staging mechanisms reduce latency during data frame uploads. By using internal stages and efficient file formats, transfers can achieve up to 10 times faster pushes compared to older methods. Practical tips for optimizing data transfer speeds include using appropriate file formats like Parquet, monitoring query performance with Snowflake's profiler, and batching uploads to balance memory usage and throughput. Security is paramount in data pipelines. When integrating Pandas with Snowflake, we must protect sensitive data throughout the process. Encryption protects data at 2 key points. Encryption at rest secures stored data using symmetric keys, while encryption in transit protects data moving between locations using asymmetric keys. This ensures data remains secure whether it's stored in Snowflake or being transferred. Row-level security restricts access to specific data rows based on user roles, ensuring users only see authorized information. Data masking techniques such as scrambling, substitution, and nullifying protect sensitive data like SSNs or credit card numbers in development environments. GDPR requires organizations to protect personal data with principles like consent, access rights, and data erasure. Key areas include communication, profiling restrictions, and secure data transfers outside the EU. Compliance involves regular audits and data protection impact assessments. HIPAA protects health information with rules including privacy, security, and electronic transactions. Covered entities like healthcare providers, health plans, and clearinghouses must ensure secure data handling, access controls, and breach notifications. Secure authentication uses OAuth for delegated access, where users grant permissions without sharing credentials. Multi-factor authentication adds layers like passwords plus biometrics. This flow ensures only authorized applications access Snowflake resources. Key best practices include data discovery, access control with least privilege, regular audits, employee training, strong passwords with 2FA, and physical safeguards. Implementing these ensures your Pandas Snowflake pipeline remains secure and compliant. Snowflake's Snowpark DataFrame API allows you to perform transformations directly within Snowflake, minimizing data movement. This API enables writing Pandas-like code that executes on Snowflake's compute resources. We'll contrast this approach with traditional connector-based methods. Snowpark enables you to write Pandas-like code that executes on Snowflake's compute resources, significantly reducing egress costs and improving performance. This approach significantly reduces egress costs and improves performance. Here's an example of using the Snowpark DataFrame API for in-database transformations. By performing transformations directly within Snowflake, Snowpark minimizes data movement and optimizes overall performance. In financial services, a major bank pushes customer transaction data frames into Snowflake for fraud detection. Using Write Pandas with chunking, they handle datasets over 100 gigabytes and achieve 5x faster model training by pulling optimized data frames back for analysis. A telemedicine provider uses Pandas to pull patient data from Snowflake into data frames for predictive analytics. By integrating Snowpark, they perform in-database feature engineering, cutting data transfer costs by 40% while maintaining HIPAA compliance through encrypted pulls. An online retailer automates inventory updates by pushing Pandas data frames from IoT sensors to Snowflake tables. Using parallel uploads, they achieve real-time stock predictions that scale to millions of rows daily, streamlining their e-commerce operations. Looking ahead to future trends, serverless architectures are becoming increasingly popular. These allow Pandas operations to run on demand without managing infrastructure, reducing costs and complexity. AI-driven optimization through Snowflake's Cortex platform will automate data frame operations and improve efficiency. This includes intelligent query optimization and predictive analytics for better performance. Deeper integration with tools like Streamlit will enable interactive dashboards directly from Snowflake data. This allows real-time data frame visualizations and collaborative data exploration. By 2026-2027, expect native Pandas support in Snowflake notebooks. This will allow seamless data frame operations within the Snowflake environment, combining the flexibility of Python with cloud scalability. Multi-cloud interoperability will enable seamless data movement across different cloud providers. This enhances flexibility and reduces vendor lock-in for Pandas workflows. However, challenges like data sovereignty and cross-region transfers must be addressed. Understanding regional regulations will be crucial for compliant Pandas operations across borders. Stay ahead of the curve by exploring these emerging trends. Consider hybrid approaches, monitor regulatory changes, and experiment with AI-enhanced tools to maximize the potential of Pandas with Snowflake.